Hey guys, welcome to Let's Talk Algorithms. My name is Venkatesh and today we'll be solving the problem word break. Let's start with the problem description. Given a non-empty string yes and a dictionary word date containing a list of non-empty words, determine if S can be segmented into a space-separated sequence of one or more dictionary words. So let's look at an example. Given an input string S, which is Leetcode, and a word dictionary, leet and code of basically multiple words, then we have to return a Boolean value which reflects whether you can form the given string with one or more number of words in the word dictionary. So since you can use leet and code together to form the whole string as the output here is true, let's look at another example. So it's apple, pen, apple is a string. The word dictionary has apple and pen. If you use apple once at the start, pen in the middle, and apple at the end again, you can form this word. As you can see, you are allowed to use a dictionary word more than once. Let's look at a negative example. Cats and dog. And you have a word dictionary which says cats, dog, sand, and cat. This is interesting. Let's look at this example a little closer. Let's form a workbook here. So cats and dog and OG actually. Like if you see there is no second D, the string doesn't have second D. So if you see the given list of words, this is the given list of words. There is a cat and there is a cats. So essentially you can break this string in multiple ways. Right. Cats and dog, yeah. So one is, let's show you multiple ways of breaking this string. So one is you can break with cats and you can also break with and. So you will end up with OG which doesn't match with any of the word in the dictionary. So this way you can't break it. Let's start with another way, which is cat, right? CAT. And then you have a word sand. You don't have any other word, which starts with S apart from sand. So you have to go for sand. And you'll end up with OG, which doesn't have any matching word. So basically, you can't form a string with the given number of given words in the dictionary. So let's look at an intuition. Um, like when we compared this example, what we did was we checked each word um, in the dictionary with the string. See if any of the dictionary, any of the word in the dictionary helps us start with parsing. Like cats, for example, help us break the string into like two parts. Cats and cats and OG. This is another string, right? So let's say we have a program which uses the list of dictionary set, and for each word you check if it matches with the start of the string, and if it matches, then you use the rest of the string to recursively call the function again. What would that function do? Again, it will check all the list of the dictionary words and see if any of the words satisfy, or when any of the words fit in this start criteria. Like if you do cats, cat doesn't match here, dog doesn't match, sand, 4 characters, doesn't match, but and 3 characters. If you see from 0 to 2, or if you're doing a substring 0 to 3, it matches. It matches the criteria. So you will use OG again as a recursive call. Then you will see that none of these strings match, so you return false. So you could use this logic. Let's write it down so it won't be confusing. Like traverse through the dictionary words. Recursively, or you can just say check if any of the words fit into the start of the given string, right? For example, cats and OG. So this will be broken into cats, comma, and OG. So if the match you are looking for doesn't exist, return false. So this is basically very simple algorithm. It runs rather very quickly because you use a process of elimination. Like if a dictionary word, if none of the dictionary words even help us start to break the word given string in the first place, then you exit with a return statement with false. So this mostly short circuit exits most of the negative conditions, so which help us gets to the positive condition like really quickly. Let's comment this out. I'll help you like let's form the helper method which takes a string and a match string again. Let's make it compact. You have a string S, a match string. That's two inputs the program would look for, and there's a dictionary which is basically the given dictionary. And so yeah, I think one big thing I probably like missed in the you know implementation detail is that this probably should be second. If you sorry, if you find match, add it to scene. This will help us memorize the matched strings. So every substring you get when it matches, use it in a map, put it in a map and send it back so that you don't like continuously look for things which you already have information on. So let's say this returns a Boolean value and let's call the helper return helper, you match the S. Initially just pass an empty string for the match. S is S, match is basically initially an empty string, and dictionary you pass word date, and for scene just initialize a map directly here. Right. So let's start with an exit condition. If length of S is equal to 0, then basically we were able to pass through the whole string and still didn't face any issues. So you return true when length of string is equal to 0. If we can have another exit condition here, if length of match, basically the string you're looking for, is greater than length of the S, or you can say if S of length of match not equal to match, then return false. So why do we do this? First thing, if match match OG, right? If we are looking for if we are looking for, let's say, sand, and the leftover S is OG, then it doesn't make sense for us to continue, right? So we return false here. Also, what we check is, this is again a short circuit exit. If this is basically substring in Golang, if s of colon length of basically from 0 to length of match, the first, if your match word is sand, if you're looking at the string, if the first words, 4 characters of the string are not match, basically not sand, then you return exit already. You don't have to check the rest of the conditions. Also, we need to make sure if what we are doing is we're checking the memoization map to see if the string we are looking for already has been calculated. If it is, then return back the result, whatever the Boolean value. Now, continue the search. So for each word in dictionary, check result is equal to helper of, pass the S, W, S is the given string, W. Also, if we exited all these conditions, we basically break down the string. Actually, we remove the condition. What this does is cats and OG is S, match is cats, S now would be and OG. So we are basically taking the substring minus the given match we looked for. Since match exists, we take it out. So in helper, you pass the string, the word dictionary word, you pass the actual dictionary, and you pass the memoization area. And once you have the result, you assign it to the scene map so that the consequent recursive calls could use the result. Also, if result is true, result is Boolean here, then return true. And if everything fails, then return false. So let's see the each of these things again. This is checking if memoization map has the result already computed for a certain string. What we're doing, check each word in the dictionary with leftover string S and process. That is what we do, right? Like here we have end OG now. So we use end OG as a string S and process. Let's add double quotes just as a way to signify that this is the string you're looking for. Alright, let's run. We have all the basic exit conditions. Unless I'm making some syntactical errors, we should be okay. Which apparently I do. Result is equal to undefined word Alright, it ran. For lead code, it said true. Let's submit the code. It's accepted, 0 milliseconds. All 36 test cases passed, and it beats 100% of the Golang online search solutions. All right, that is it. It's a simple recursive solution with memoization to avoid computing multiple values again, which could take more time. And this also uses the short circuit exit uh, logic. Basically, since you can just look through the dictionary words and see if any of these words fit in at the start of the string. If it doesn't, then you could already exit, right? Uh, if you have any questions, please feel free to post a comment on the video and subscribe to the channel if you like to see more videos of this kind. Thank you.